Okay, that should be recording. So just to recap, then, when we look at radioactive decay, the word decay, I'll just annotate on my screen. The word decay is the process. So it's a process. So it's actually something is going to decay or has decayed, um, where an element um, spontaneously becomes another element, or we could say maybe a type of atom, but that's fine. Becomes another element. So here's an example of decay right here. When I press play, we have an isotope, and we might want to look at the word isotope later on, but we have an isotope of hydrogen. Basically, we have a type of hydrogen. When we think isotope, think type. A type of hydrogen. This type of hydrogen is what we call unstable. Now, if it's unstable, um, it means it may decay at some point. Well, it will decay at some point. So this is a verb, and this is an adjective, and so something's going. So it means it can decay. Something may decay. If it's something may decay at some point. Well, yeah, it will decay. It will decay, but we just don't know when. Okay, it will decay. So this hydrogen, this type of hydrogen, this isotope of hydrogen, is going to decay because it's unstable. And what does that mean? Well, let's press play and find out. Okay, so it's shaking around. I don't know if we can really say it shakes around normally, but yeah, it's something else. It's not hydrogen anymore. Let's have a look. Let's write that equation down. We started off with hydrogen, which has an atomic number of 1. All hydrogen atoms have an atomic number of 1. So every type of hydrogen, or every isotope of hydrogen, has an atomic number of 1. This particular type of hydrogen, or isotope of hydrogen, had a mass number of 3 because it had 2 neutrons. Most hydrogen doesn't have any neutrons. Most hydrogen atoms don't have any neutrons. This one did. So that's what it looked like. And when it decayed, it changed into helium. Now, helium doesn't seem to be shaking around quite so much, so basically that's the animation's way of saying that it is stable. So it's still got a mass number of 3, and the atomic number is 2 because it's helium. All helium atoms have an atomic number of 2. They don't all have a mass number of 3. Some of them have a mass number of 4. In fact, 4 is more common. But this one has a mass number of 3, but it is stable. Now, the other thing, if we reset it again, you probably noticed that something else was given off. This stuff that was given off, we can refer to as radiation. So when something decays, it gives off something called radiation, and it gave off 2 things there. And you can see up here on the right, there's a key. It says electron and an antineutrino. But when they first detected it, they probably didn't know that it was an electron, so they just called it a beta particle, and they knew it's a negative charge. Now it also gave off something called an antineutrino, which looks like that, but you don't need to know that for GCSE. That's A level, so let's just forget about that. So basically, it gave off a beta particle, and then now this beta radiation or beta decay. Let's look at what's the difference between beta radiation and beta decay. Radiation is the stuff that gets given off. So radiation. So they're both nouns, aren't they? Beta decay, beta radiation. They're both nouns, but decay. Oh my god! Decay is a verb or a noun. So decay, for something can decay, but also we can describe the process as a decay. So Beta decay is simply describing the type of decay that is happening. And the one that we've just seen, that process that we've just watched, that's beta decay. Okay? And this is an equation describing beta, an example of beta decay. Beta radiation is this thing here, the thing that gets given off. More precisely, it's a beta particle, but it is a radiation because it's the stuff that gets given off. Now, when we looked at it more closely, we found out that it's actually a beta particle is an electron. But they really want you to notice what's weird about this. Because if we look at before, we reset it, inside this hydrogen nucleus is 2 neutrons and 1 proton. So where did this electron come from? You don't need to know where it came from. You just need to know that it's weird that it seemed to come from nowhere. And in other words, if they say to you, what is a beta particle? It's a 2-mark question. A beta particle, 1, it's an electron. 1 mark. Okay. 2nd mark, it came from the nucleus. From a nucleus. Okay. Nuclei don't contain electrons, so how did it come from the nucleus? Well, it just did. Let's just say that. Okay. Something very strange happened. Despite the fact that we say electrons don't live in nuclei, we then said, but that one just came from the nucleus. And so, well, there's no electrons there, are there? But magically, it seemed to come from there. Well, let's just you might be able to see what's going on, even if it doesn't really make much sense. But that red thing there used to be a neutron. So a neutron just randomly changed into an electron and also a proton. And the proton sat where it was and formed the nucleus of this new atom, which is now helium. And this electron, we called it a beta particle, and it shot off. It wasn't there before. There was nothing added to this. This is just a neutron became an electron and a proton. This is the basically a summary of all beta decay. So if we look at another example of beta decay, the one that I usually give an example of, which is carbon-14, well, maybe we could work out what would happen. I gave you one example of beta decay. Let's write well, carbon has got because it's carbon, it's got an atomic number of 6. This particular type, or this particular isotope of carbon, has got a mass number of 14. So I'll pause it, and if you were watching it again later on, then this is when you would try to answer the question. And obviously anybody else watching this does the same thing. We're going to pause it, but you're going to do it now and see if you can work it out. Okay. Right, so you predicted that carbon-14 is going to change to nitrogen-14. Let's go to carbon, press play, and, well, you are right, aren't you? There you go, yeah. So, and yeah, so we can see, once we realise what's actually going on here, and one of the neutrons has been turning into a proton and an electron, then you can see, well, the mass number is going to stay the same, like it does here, and the atomic number goes up by 1. Mass number stays the same because there's the same amount of nucleons inside the atom. There's a word for you, nucleon. Nucleon is just a particle that lives inside the nucleus. So therefore, it covers protons and neutrons. Okay, nucleon, spelled like that. Nucleons, protons or neutrons. Okay. Okay, so that's a summary of beta decay. The process, that whole thing, these 2 examples and that general equation down here describes beta decay, ignoring the antineutrino, which you learn about at A-level physics. And then the beta radiation is the stuff that gets given off, that gets emitted, which happens to be an electron, and you need to remember to say that it came from a nucleus to get that 2nd mark. The word decay refers to the actual process, so beta decay would be this, as I said, this whole process. Unstable is the adjective to describe the things that can decay. Okay, and let's have a look at alpha decay.